So we're going to be looking at how to calculate the average rate of reaction when you're given a table of values. So in this table of values you have here is essentially a timeline of a reaction. So we have the time, and every 30 seconds we take a measure of the volume of ethyl gas produced. So at 0 seconds we have 0 centimetres cubed of gas produced. The reaction hasn't started yet, so no gas is being produced. After 30 seconds we have 60 centimetres cubed of gas produced. After 60 seconds we have 96 centimetres cubed of gas produced. After 90 seconds we've got 120 centimetres of gas produced, etc., all the way up to 210 seconds and 152 centimetres cubed of gas produced. So you can see the last two values there. After 180 seconds the reaction stops at 152 centimetres cubed of gas produced. After that point no more gas is produced, so the reaction has plateaued, the reaction has stopped. So the question is asking, calculate the average rate of reaction between 60 seconds and 90 seconds. You must include the appropriate units in this. So the units you're going to be looking at are the units for volume, centimetres cubed, and the units for time, chart in seconds. So how do we calculate the average rate? Well, rate can be worked out using the relationship on page 3 of your data booklet. It's the fifth relationship down, second from the bottom. It is rate is equal to delta quantity over delta T. So delta means change in, and quantity just means the thing that you're measuring. So the quantity we're talking about is volume, the volume of gas produced. So the generic equation would be rate is equal to delta quantity, or a change in quantity, over the change in time, or specifically for this reaction, change in volume over change in time. So what we are asked to do is calculate the average rate of reaction between 60 and 90 seconds. So between 60 and 90 seconds means that you're looking at a 30-second period. So the change in time is going to be 60 minus 90 minus 60, sorry, which is going to be a 30-second difference there. And what we want to look at, if we just take this back over here, if we want to look at is how much volume is produced at 60 seconds, how much volume is produced at 190 seconds. So at 60 seconds we have 96 centimetres cubed, at 90 seconds we have 120 centimetres cubed of gas produced. So let's just fit that into an equation. So the change in volume, we're looking at how the volume has changed in that 30-second period. So at 90 seconds we have 120 centimetres cubed of gas being produced, and at 60 seconds we have 96 centimetres cubed of gas being produced. So what we want to think about before we do anything is that it does state in the question that you must show the units, the appropriate units, to get the full marks in this question. So the units for volume we're going to use are centimetres cubed. The units for time we're going to use are seconds. So centimetres cubed divided by seconds. So if we just simplify that down, we're going to get 24 centimetres cubed divided by 30 seconds. So now you want to do is to simplify that even further and calculate what answer you get. So 24 divided by 30 is 0.8, and the units are going to be centimetres cubed per second. That forward slash means divided by seconds. Another way you could write it would be 0.8 centimetres cubed seconds to the minus 1. Both answers are valid. So that's how you work out the average rate. You look at how the change in volume, how the volume has changed, and how time has changed. Fire it into that equation and remember to use the appropriate units.